Welcome back to OCR and MEI task paper walkthrough. Today we're doing C4, June 2014, section B. So let's have a look at the questions. So for question 7, we have basically a geometry question, but it's in 3D. So this is one of the most typical C4 questions for section B. Now, we have a few points that were given, A, B, C, and D. And for part 1, we need to find the length of the edge AB and AC. So that isn't too difficult. To find the length of edges, basically you undergo the equation for a vector R is essentially the vector of -3, 0, 0, that is A. And if you subtract that by B, which is 2, 0, and -2, so now we have A take B, then we would have from B to A, so R will equal to BA, and that is equal to A to B, which for that would be -5, 0, and 2. And in order to find the length, we don't want the vector, we want the modulus, so we want to mod R, which would just be a -5 squared plus 0 squared plus 2 squared. And that gives me 25 plus 4, 29. But that would be R squared actually. So to get R mod, it's just the square root of 29. So that's AB. Now we can apply the exact same logic to A and C. So we have A, but we take C this time. So instead I have C with coordinate 0, 4, 0. And that would give me apologize for that horrible handwriting, but yeah. Anyway, A take C would be -3, -4, 0. And that mod essentially would be -3 all squared plus -4 all squared plus 0 squared. That would be R squared. And R would be, that's 9 plus 16, 25, square root of that is just 5. So that is an integer solution. Now, with that, we want to find the size of the angle CAB. So we have, let's see, this is AC equal to 5. So we now do the calculation on the angle. We know from dot product that to find the angle, we can do the factor of AB, factor of AC dot together. So AB dot AC, that would give us cosine of the angle theta multiplied by the modulus of AB AC. So we have that information. We know that the mod of AB and AC are the following that we've calculated, which means that we can just substitute things in. So let's do the left-hand side, AB.AC. So as we've done, we know that AB is minus 5, 0, and 2. Well, that is BA anyway, but in terms of direction, we just need to be consistent. But if you swap the direction, it would just give you the obtuse angle, or if that's the case, then you just need to do a 180 subtract. So that's not that big of a deal. So since we've done B to A, we should also use C to A. And to get C to A, we have done, as we have done just now, was minus 3, minus 4, 0. So if we've got that, then we can divide that whole thing by 5 root 29, because that is ABAC. And that would be cosine of theta. And in terms of dot product, you just do the x times x plus b, y times y plus z times z. And in this case, because y and z are 0, we just need to do the top 2, which is 15 on 5 root 29, and these cancels. So cosine of theta is 3 on root 29. And so if you use your calculator to do an arc cosine function, you should get, well, depends on what angle mode you use. You can get a few solutions, but if you use the angle mode, you should get 56.15 as your solution. So these are in degrees. Now we've done that part. Now the last part of this part 1 is calculate the area of the triangle ABC. So area of a triangle is half AB sine C. So in terms of a triangle, if you have side A, side B, and angle C, the solution to the area A would be half AB sine C. So we know that in this triangle that we want to find, C is 56.15, A, B are root 29 and 5 respectively. So if you just sub all the numbers into the equation, you should get that the area is just 11.18 unit squared. So probably best to write down the unit square, but I don't think the mark scheme includes that part, so it should be fine. And these 7 marks are quite difficult to get, because it basically challenges you to understand exactly what all those 3D geometry means and how they work. But as long as you know how to find the modulus, or the distance between 2 points, it should be quite straightforward. Also, just remember the standard equations like half AB sine C, and it would also help if you remember dot and cross products. Now for part 2, we want to verify that 4i take 3j plus 10k is normal to a plane ABC. So let's have a try. Right, so in order to find the normal of the plane, we want to make sure that the plane, any line on the plane is perpendicular to the normal. So essentially we want to do 2 dot products and get the value of 0, because 0 is cosine of 90 degrees, and in order for the 0 to be a valid solution of the dot product, the 2 dots must cancel out. So let's have a try. So the first dot we want to do is 4 minus 3, 10 dot onto, let's take our original BA line. So BA is minus 5, 0, 2. And if we do the dot, we get minus, that would equal to minus 20 plus 0 plus 20, which conveniently gives us 0, and therefore our cosine of 0 is 90 degrees, and so it is perpendicular to that one vector. But because we're doing it in a 2D plane, we need to find another line that is not parallel to AB that satisfies the same condition. And conveniently, we know that AC is not parallel to AB from just inspection. And so we can do the same with AC. So we have 4 minus 3, 0, 10 rather, dot of, let's see, AC would be minus 3 minus 4, 0. And this dot gives us 4 times minus 3 is minus 12, minus 3 times minus 4 plus 12. And that would just be a plus 0, and eventually that would give me a 0. So that is exactly the same as we have found previously. And so because these are both zeros, we can just deduce that 4 minus 3, 10 is perpendicular to ABC. So that's part A, worth 2 marks. Quite a lot of work for 2 marks, to be fair, but I guess that's life. You've earned quite a lot from previous parts. And now we want to find the equation of the plane, which, because we have normal, it's a lot easier. And they've given you the normal. So even if you can't do part A, you should be able to find part B, which is nice. So let's see. For the equation of a plane, it's always the normal factor dot xyz. So it would just be 4 minus 3, 10 dot x, y, z equals to a constant c. And so we know that 4x minus 3y plus 10z equals to c. And I don't know what c is. C is a constant we need to find, and so we can just substitute values. If I take point C as our reference point, we can tell that x is 0, y is 4, so that's minus 12, plus 10z, z is 0, gives me minus 12, so c is minus 12, and therefore I can state that 4x minus 3y plus 10z is minus 12, or you can equal to 0, 4x take 3y plus 10z plus 12. Note that I have set z and z, but it really doesn't matter, you know what I mean. I'm not a linguist or an English student, so pronunciation ain't that big of a deal in math. Right, so part 3, we have to write down the factor equation for the line through D, perpendicular to plane ABC. So basically we want to find a factor that is perpendicular to ABC, and we know perpendicular to ABC means that it's a normal to the plane, and so the general equation of that line would just have a factor direction of 4 minus 3, 10. So I need to add something here, so the something is the lambda, and typically we would add the point of reference, so that's just 0, 4, and 5 for D, and that would just be our factor equation. So that's rather straightforward. Hence it's like write down a factor equation, so you can just write that down backwards. Now we want to hence find the point of intersection of this with the plane. And the plane equation, as we have found previously, was 4x minus 3y plus 10z plus 12 equals to 0. And so we can now find x, y, and z in terms of lambda. So let's have a look. For our x is just 0 plus 4 lambda. Whoops. Y is 4 minus 3 lambda. And z is 5 plus 10 lambda. So literally just read it off this row by row. And now we have this whole mess that we can substitute in to give me 4 times 4 is 16 lambda minus 3 times 4 is 12 plus 3 times 3 is 9 lambdas plus 10 times 5 is 50 plus 10 times 10 is 100 lambdas, and that plus 12 is 0, so that would give me minus 12 plus 12 and 50, let's see. Yes, so 50 goes on to this side to, my pen ran out of battery. Be right back. Sorry about that. So we have minus 50 on the right, then we have 16 plus 9, 25, plus 100, 125 lambda, and that would give me lambda is, let's see, that would be 25, 10, and that is just 2 on, minus 2 on 5. So that's the separation between D and the plane. And in order to find the point of intersection, we just substitute this lambda value into the original equation. And so I have 0, 4, 5 and minus 2 on 5 times 4 minus 3, 10. That gives me 0 minus 4 times 2 is 8 on 5, and 4 plus 6 on 5, and we have 5 minus 4, which gives me essentially minus 1.6, and that would be 5.2, and that is just 1. So this is the solution for the basically 3D simultaneous equation of the line and the plane. So that's part 3, and finally we have find the volume of the tetrahedron. Okay, so the height or the point of intersection would be useful here, so I'm keeping it. And so we have the base is minus 1.6, 5.2, and 1. And so to find the tetrahedron volume, we want the area of the base, which we have already found previously. So it was half AB sine theta, which is 1.18. So area of base is 11.18 rather, not 1.18. Or maybe I said it right, but I just forgot what I said. We want to find the height, and the height is d to ABC in terms of the plane perpendicular length, and we have found the intersection point, and we just need to find the mod of this difference between point D, 0, 4, and 5, and the base, that would be the height. And let's see, that would be minus 1.6, and 5.2 take 4 is 1.2, then we have minus 4, and to find the actual height is the, height square is 1.6 squared plus 1.2 squared plus minus 4 squared, which is 20, and so h is just root 20. So I've got that part, and we just need to use the given equation, 1/3 root 20 times 11.18. Yes, that should give us 16.7 units cubed. So that's the solution for question 7. So question 8 is a kind of rate equation kind of question. So we have a leaking tank. So let's start with part 1, verify that the solution to the dE is h equals to 1 take half at all squared. So the dE is dh by dt equals to minus a root h. And to do the differential equation, we can separate variables to minus a dt is h to the power minus a half dh. So it's always better to put everything in power form. And so we can do the integration for the dt to get that minus at is h to the plus a half. That divided by a half, which is just multiplied by 2. Bear in mind you have plus c there. So the plus c includes the plus c from the dt and dh. And we don't actually know what everything is at this moment, so we want to find c. Initially the water surface is 1 meter above the hull, so we know that height is 1 when t is 0, so 0 is 2 times 1 plus c, which gives me that c is minus 2, and therefore if you substitute this back into the original, you get 2h to the half minus 2 is minus at. And you just need to do rearrangement. Now you get 2 take at is 2h to a half, and you can divide both by 2 to get root h is 1 take half at, and therefore if you square both you get the given solution. So that's pretty much just algebra. And the water stopped leaking when h is 0. This occurs after 20 seconds. So when water stopped leaking, we define it such that dh by dt equals to 0. So when this happens when t is 20, and we want to find the value of a and the time when the height of the water surface is 0.5. Okay, so we can try to find a first. So let's see. We know that the height is 0 when water stops leaking, which is quite obvious because it's when the water runs dry, right? 0 is equal to the solution of 1 take a half a t. T I know is 20 seconds squared. And this square really doesn't matter at this point because 0 root is just plus or minus 0, which is just 0. And so we can state that the thing in the bracket is 0, and therefore 1 has to be half a times 20, which means that we can first cancel things, so we get a 10a is 1, and therefore a is 0.1. So that's rather straightforward. Now with that, we can find the time when h is 0.5. So 0.5 is equal to 1 take half lots of 0.1 t all squared. And this time the square matters, so we've got root 0.5 equals to 1 take a half times 0.1 t, and that would just be 0.05 t, 1 take root 0.5, and therefore t is 1 take root 0.5 divided by 0.05, which gives you something along the line of 5.86 seconds. So this is the solution for part 2. In part 3, we have used a different barrel, which means that the rate would be different. And you'll be glad that they did give you the equation for the rate. But this time we have a constant b. Solve that differential equation. Okay, so this is going to be a tad bit more tricky, but still doable. Let's see. Alright, so it's still gonna be a separation of variable, which is not that surprising. 1 plus h all squared divided by root h dh equals to minus b dt, and that would just result in minus bt, and let's have plus c on this side this time. And on the left hand side, this is going to be a tad bit tricky. Let's see. So we can split this thing into 3 terms, because we can just break open the power for this purpose. Then we have a large integral 1 on root h plus 2h on root h plus h squared on root h dh. And this bit we can just integrate each of the part by itself. So h on root h is root h squared on root h is h to 3 halves, and 1 on root h is h to the minus a half. And so if we integrate these, you get, let's see, so this gives me 2h to the half, that plus 2h to the 3 half divided by 3 halves plus h to 5 half divided by 5 halves minus bt plus c. And so we can simplify 2h to half, add 4/3 h to 3 halves, add 2/5 h to 5 on 2, this minus bt plus c. Alright, then now we want to use the boundary condition when t is 0, h is 1. So let's have h is 1. When t is 0, we know that c is on the right. T is 0 minus bt is 0. So on the left we have 2 times 1 plus 4/3 times 1 plus 2/5 times 1. And let's see, so this would give me something on 15, and that be 2 is 30 plus 20 plus 6 equals to c, and so that would be 56 on 15 equals to c, and therefore we can now write the whole equation out. Let's see, I should do it. I know that we have 2 extra half plus 3, 4/3 h 3/2 plus 2/5 h 5/2 equal minus bt plus 56 on 15, and if we multiply both sides by 15, the equation would still hold, and so we would get 30 h to the half plus 20 h 3/2 plus 6 h 5/2 equal to minus 15 bt plus 56. And if you rearrange everything and factorize on the left root h, we get h to the half times 30 plus 20h plus 6h squared equals to 56. Take 15 bt, which is the given equation. So that's 7 marks in the bank. Now we have the last part of the paper, part 4, given the h is 0, t is 20, find b. Okay. This can't be that much harder because it's only, what, 4 marks. So h is 0, everything on the left is 0, equals to 56, take 15b times 20. Therefore 56 is just 300b, and so b is 56 on 300. So 56 on 300 in calculator is 0.187, and with this information we want to find the time when the height is 0.5, so when the tank is half full. Well, the height of the tank is half. So we have 0.5 root times 30 plus half of 20 is 10 plus a quarter of 6, so 6 quarters is equal to 56 minus 15b t. And so essentially you want to use your calculator So we know that 56 take 15bt is just calculator give me 29.34. And if you rearrange to 56 take 29.34 is 15bt, and you divide both sides by 15b, you get 56 take 29.34 on 15b, and that results give you 9.52 seconds. And so that is it for this paper. And yeah, overall the paper is, not gonna lie, it's a bit standard, and most of it is quite on the aspect of you either did revise and remember how to do things, or you just don't know how to approach it, which means that for C4 it's actually quite standard, quite easy to just revise and manage to learn everything, because every single questions are one of the hand crank, remember the steps and just repeat, almost like a machine kind of thing. So yeah, nothing too challenging for this. Anyway, this would be it for me. Hope you've learned something, and very good luck to your exam, and I'll see you on my next one.